we have discussed in last class? Can you recall
Iterative method, sir, to find out solutions.
which method?
Like yes, sir.
Gauss
Iterative
seidel.
बोला ना sir. A Gauss seidel method. हाँ,
Right,
Gauss seidel
Gauss
method.
seidel method for uh, nonlinear equation, right? To find the solution for nonlinear equation. Today we will try to observe the case in terms of another methodology known as Newton-Raphson concept. Actually, how we can address that solution approach, today we will discuss regarding that. For that, if you can recall the equation or the function, this was the function, right? The last class, if you can recall, or if you have the last class lecture, the equation was x3 cube minus 6x square plus 9x minus 4. That was the nonlinear equation for what we have determined the solution in terms of Gauss seidel method, right? Using regular approach as well as acceleration factor concept. And for normal approach or regular concept, we have the iteration for 8 iteration, we have reached the result, and for acceleration factor, it was less than that. Today, when we consider the other method, which is known as Newton-Raphson method.
Sir, one question, sir. Sir, before you proceed, sir, one small question, sir.
Yes.
Last day, sir, we found the solution in the 8th iteration, sir, right, sir?
Right.
So, sir, while we were doing that, sir, my basis of conclusion that this is my answer was
Okay.
that same value came twice. So it's like the 7th and 8th value came close to each other or very same. That is why we said that that is the value.
Right. Actually, the
Right, sir?
convergence issue, that means what is your input that satisfy as the output. That's why you can conclude the session or conclude the
Yes,
result.
okay.
That is the outcome or answer. Okay. If it does not match, in that case, you have to continue more. And sometimes in the problem, it might be mentioned that you have to find the solution in terms of that accuracy level. Like it might be 10 to the power minus 4. Okay, that means the fraction response for input and output must have satisfied that condition. That means error limit between input and output. It might be there or it might not be there. Sometimes you may have the error limit. Okay, error limit to consider the result or answer. But for last class, it was not mentioned that what should be your error limit or how can you define or define the result as output. Actually, the input satisfy the output. That's why you don't need to bother about. Sometimes the response is so small, like 0.00, then you have the answer response. In that case, you might need some accuracy. That means accuracy level 10 to the power minus 4, say for example. If it is mentioned 10 to the power minus 4, that means after decimal point, you have to satisfy the result on that scale. It might be there sometimes. Okay, the accuracy level considering the result, whether you have reached the result or not. But this case, it is not mentioned. The result was quite same. That's why it is not the matter of botheration. So today we will discuss another approach, which is Newton-Raphson concept, to solve that same nonlinear equation and try to observe what is the scenario for that concept to get the solution. So what you have to do, first of all, when you approach this method, what will be your different step to address that Newton-Raphson method. First step is to consider the response in terms of derivative. Okay, this is the nonlinear equation, right? The third order nonlinear equation, because of x to the power, x has the power of 3, right? So find the step 1. Determine the derivative of this nonlinear equation. What will be the derivative? It will be 3x square minus 12x, right? Plus 9. Have you got that? The derivative in terms of its variable x. Okay.
Yes, sir.
So that will be the response. Okay. So derivative response. Uh, so this is the first step. This is the d function of, this is the function and this is the derivative, which is 3x square minus 12x plus 9. First step is the determination of derivative. In some problem, you might have multiple derivative. Okay, that means multiple variable, multiple unknown quantity. Here you have only one variable or x, right? But in some case, you might have more than one variable like x1, x2 or something like that. That means you might have two equation and two unknown variable. In that case, you have to determine based on partial derivative. Okay, partial derivative concept. For this case, it is the simple derivative, as it has only one unknown unknown constant or other variable. So second step is to find the function. This is the fx function, and if you have that fx function, that function value, that means the initial value must be there. For this case, the initial value is considered as 6. It will be given to you in the problem definition. So if you put 6 is that equation, what about x6? That means first x0 as 6. This is the x0 as 6. Function of x0 as 6 in terms of c minus f x0, like that. That means put the initial value to the nonlinear equation, this equation. Okay, then that will be c minus that variable, that means in terms of initial value. Okay, and that will be first c, that means del c0. Actually, this methodology of Newton-Raphson concept has the option of derivative, and derivative is nothing but the continual increment or decrement scenario, right? From the from its original or initial value. Say for example that we have assigned randomly the 6 as initial value, but derivative will confirm the matter whether we will consider the next iteration as greater value than that, the given value, which is 6 for this case, or less than that. Okay, that means incremental behavior of the function. And I think you have the idea of Taylor series expansion, right? Taylor series expansion in math. Do you have the concept of Taylor series expansion? Actually, in Newton-Raphson method.
ভুলে গেছি স্যার অনেক কিছু স্যার মনে আছে বাট অনেক কিছু ভুলে গেছি আবার স্যার yes sir.
Discuss that issue also. Actually,
Yes,
the Taylor series, that means if we just think of this function, okay, this is the function, actually this is the regular function, right? Fx equals c. C is the other side parameter. For this equation it is actually 0, and this equation fx can be considered as x of initial value in terms of the derivative response of initial value. That's I have mentioned. So derivative will be the increment or it might be decrement scenario. This is the initial position of x, and based on that x, you might have some that means extension or decrement of that value. And if we just think of this as first term and that is second term, this part is nothing but differential response, right? This is the differential or the functional incremental response. That is ddx of x, right? This part. Have you got that?
Yes, sir. This is a small change, sir.
Yeah, small change, the increment or decrement scenario, then that small change can be written like this one, this form. That means you can actually del x is nothing but the ddx, ddf of x, and that has the zero position. That means the first iteration. So if we just think of x0 plus that in differential response, and that is the, you can say, as the basic equation like f a plus b or something like that, then the Taylor series expansion will be something like that. That means f of this part, then you have the function that part multiplied with del x0, and then you have the factorial part, which is second order of differential response in terms of it. In this way it will have the other uh, term, right? The third term will be the differential response in terms of third order, where you have factorial response like that. 3 might be there, and the power will be also increment like 3. Actually, our consideration is the higher order term, like if it is the differential response and the higher order, if we just consider of square or cube, that will be small, right? And we can neglect that smaller quantity, just considering these two terms. Okay, this first term and this second term, excluding the rest. That means the extended version of the Taylor series. Okay, because this x0 is small, and if you just put the square there, that will be less than the given value. If it is 0.5, square will give you 0.25, right? So
Yes, sir.
we can exclude the higher term order of the differential, only consider this part, and this function is the actually the partial derivative or the regular derivative. Okay, so if we just shift that functional response, that means this part as del c0, this total part as del c0, then the function something will be like that. That means del c0 will be c, this is the c minus fx, that part will be there, and del c0 will be in other side. And lastly, we have this relation. That means uh, this will be x1, the second iteration x0, and del c0 of function of that. The second approximation will be something like that. Okay, uh, x1, this is the first iteration. So actually, if we just think of this mathematics, it will be difficult. That's why I have discussed regarding the issue of problem issue, so that you can get the idea in terms of some numerical response and to get the idea clear. Okay, so first step is the differential response of the given nonlinear equation. Second step is to generate this type of initial value in terms of CS0 minus the function value. And another one is the, if we just put that differential response as the initial value, what will be that? That means ddx of f as initial value 0. What will be the value for that differential response? Put x as
Sir,
fixed.
করতে হবে স্যার, একটু করতে হবে স্যার।
Yes, try. Let's try the response for that. That means find the value if you put 6 there.
Sir, 45, sir, 45.
Okay, positive 45. So you have regular function which will give negative 50 in terms of C minus function, and the derivative response, if you put the initial value, it will give positive 45. Next step is to get the result in terms of, this is the positive 45, right?
Sir,
Next,
sir, before that, sir,
yes,
one small question, sir.
yes,
Can you kindly go up, sir? One small question.
yes. Is it
একটু
there?
উপরে যেতে হবে, sir. হ্যাঁ. Sir, এখানটাতে, sir, here you did, yes, sir. Here you did del C of 0 is
Right.
equal to C minus F of X0.
Yes.
Yes, sir. So here, why did you take the value of C to be 0 here in this
Actually,
part? এখানে C
is,
valueটা 0 নিয়েছে.
yes, C, if you can, for that, you have to check the given formula, okay, or given function. The function is actually fx, okay, and fx, it doesn't have any value. If we just consider that fx, it will be equals to 0, right? For
So if
that,
I
yes,
put
if
6
you
in
want,
the equation.
yes, if you want to make that equation in that, not 6, actually like that. This is the functional regular response, okay? If you just compare these two equation, fx equals actually C, and for that case you don't have any value. That's why fx equals, it will be the other part. If function has some similarity, or function has some equational response, C will be in that case the 0 response for that equation, the given nonlinear equation like this one, fx minus C is 0, so C will be the other part which is 0 for the other side if there is not anything. So this is the general format to consider C minus fx of initial value. And the second one that we have already find, positive 45. Okay, first of all, you have to find derivative and put that value in that. Second case, that del x0, this is the incremental response in terms of del c0, that is minus 50, and the derivative 0. Okay, these two value you have just find. The upper value is for the function itself, right? And the lower value is for derivative response with the initial value. When you have the division, this will give you the response for next iteration, and that will be this one. That means x1, next iterative response will be x0, which is initial value as 6, and this is the differential response in terms of the function, which is minus 1.11, something like that, right? So this will be the next iteration value. So next iteration, what you have to do, del C0, when you want to determine, you have to use this value 4.8889 instead of 6. Okay, put that value to determine first del C0. This is the equation. Okay, in that equation you have to put the value of del C0 x as, here you have to put x as 4.8889 instead of 6, because of it is the second iteration. Okay, this place.
So the C will remain 0?
C will remain 0, right? C will remain 0 because you don't have the change for C. Only the function has the x value change, second iteration. So what will be the response for that? As well as the derivative response, you have to put that value, 4.8889, right? 4.8889, right? This value.
Yes, sir.
This value you have to put this equation as well as that given regular equation, regular nonlinear equation. which will give you del C1. So what you have got from nonlinear equation when you put 4.889?
So should we do that?
Yes, you have to do actually. Otherwise, you cannot
Okay.
get that point.
Okay, so doing it. So it comes as minus 13.44.
Okay, minus 13.44 for which value? Del C0, right?
Del C0, yes.
Right. Now you have to find this part. That means the denominator part as well. Put the value here. Instead of 6, you have to put this value.
$22.037, sir.
Okay, 22.03. So then apply the concept to generate this equation. That means what will be then the equation response? That will be x2, and this will be replaced by x1 plus del x1. This the second iteration response will be del x1. So del x1 is the division of this, right? Minus 13 point something over 22 point something, right? To generate that
Yes, sir.
value. And this will not be 6 for that case. It will be 4.889. Okay.
4.889.
Yes. What will be the x2 value then?
So 4.2789.
Okay, fine. You have generated the second iteration response correctly. That is 4.2789. Using the same methodology, you have to apply the third iteration as well. Actually,
So why do we use this complex method, sir?
Actually, this
we had the previous one, so the Gauss-Seidel one.
Right, Gauss-Seidel one requires 8 step, right? 8 or 7 step.
Yes. Sir.
This will require less than
Yes.
that step. That's the advantage. Or though it is some complex, but iteration response will be lesser. Sometimes for critical situation, like if you have large power system, like 30 bus system. In that 30 bus system, if you want to find the 30 unknown variable and each one requires 8 step, it will have, say for example, 240 result generation, right? And in that case, if it is reduced by, say for example, 3 steps, it will actually reduce huge number of calculation complexity. That's why sometimes it is required to apply some other method. Actually, that will depend on the situation, which methodology is suitable or which one. You have to know all the idea or approach so that you can address based on your requirement.
Yes, sir.
Now, have you got the equation or write down the equation, the regular equation, so that you can determine a del C 1 or 2.
2, sir. Now we'll have to. We are done with 1, sir. Now we
Right,
will do
and now
2,
you
sir.
have to use del C 2.
Sir.
This will apply
এভাবে
actually.
করে করতে হবে।
You have to find the third iteration response.
Yes, sir.
Actually, in some texts, this derivative part is considered as Jacobian matrix as well, especially for multiple variable scenario. Okay, like this case, you have only one variable x, but in some case, you might have more than single variable like x1, x2, x3. You might have multiple variable. And for that case, you need to address the issue of partial derivative in that case. For this case, it is simple derivative because of single variable. You have the regular equation in your hand, right? Because here you don't have the regular equation, so that you can put this value 4.2789 for the next iteration. Have you got del C1 2?
Sir, del C2, sir,
minus 3.0005.
Okay. What about function differential response?
আমার final answer আসে স্যার 4.0405.
0405. I think you have got the correct result. Let's check. This is the result, right?
Sir, আমার 4.5 আসে।
4.0405 will be the correct result. Okay. So
I think ওর একটা ছোট্ট ভুল হয়েছে স্যার। ওর মনে
আচ্ছা
আপনার del C টা একটু ভুল হয়েছে স্যার probably। জি।
চেক করো দেখো তাহলে পাবে। Del C0 you have to check whether you have got this value del C0 2.99 or anything else. Then apply that 4.0405 for next iteration.
তাহলে 4 আসে।
Have you got 4?
Yes, sir, 4.001.
Okay. 4.001, right?
Yes, sir.
Then put that value for next iteration.
Exactly 4, sir. 4.00000.
Right. That means you have reached the result in fifth iteration, right?
কিন্তু এটাই যে রেজাল্ট এটা আমি কিভাবে জানি?
Because if you just put that value again, it will give the same result, and that's the response actually for Gauss Seidel as well. That whatever you have put, you have generated the same. So if you just put that value for the confirmation, you can cross check whether you have got anything else or not. And another thing, the erroneous limit for that case, you can see 10 to the power minus 4, right? The error limit, or you have
Yes.
got rid of all the zero. So the deviation response for the result from the iteration response from the earlier iteration, it is 10 to the minus 4 accuracy level.
Yes, sir.
So this is the thing of is Newton-Raphson. So if we just wrap up all the concept what we have done, first of all, when you have been given any nonlinear equation, you have to generate the derivative of that nonlinear equation. It might be single variable, it might be multiple variable. Like for this case, it has only one variable or unknown quantity x, but in some case you might have multiple variable. Okay. Second step is to find the value of the regular function as well as the derivative response to generate del x0, right? From the division, and from that you can find x1, that is the next iteration value. And in that way, after some multiple iteration, you can generate the outcome or the result. That's the step for Newton-Raphson concept to solve the nonlinear equation. Now we want to see or observe.
Sir, আমার খালি একটা question, sir.
Yes.
Sir, the question is, sir, like in this case, C was 0, sir. অন্য
Right.
case, the C value can be different. So what do we do then, sir? How do we find it out, sir?
Actually, if it is there, in that case, you can use C as that value. Fx equals that value will be given. Fx equals C, C will be there for that case. And if it is there, say for example, we might see something like this one. Okay, in that case, you can see Fx has some value of 4 or 1, right? In that case, C1, you have two function, right, for this case.
Yes, sir.
And yeah, there you can see this equation format has some value of 4 and 1. So in that case, you can say that C1 is 4 and C2 is 1. Okay, or two equation. And the earlier case, as I have mentioned, the function was only one variable, right? But now you can see you have two variable, right? X1 and X2, as well as you have, as you have two unknown quantity, you must have two equation, okay, to solve that. First one, can you identify the equation? What types of equation this one?
Sir, ellipse.
Oh, this is circle actually, right? Simple circle.
It's a circus.
Which has the radius of 2, right? Circle,
Yes,
circle
yes.
equation. And second one is the exponential equation starting from 1. So
Yes.
this is the graphical response of that two equation. Okay, this is one circle, another one is the exponential response in terms of 1. So for these two equation, if you are asked to determine the solution means the intersection of these two curves, okay, this point or this point. So you can start the job from either this side or this side. Actually, one for Newton-Raphson or Gauss-Seidel or any problem, you might be asked to find one solution only, but all the problem has multiple solution based on its nonlinear equation, right? Polynomial order. If it is third order, you have to have three equation, but three solution, but we only want one solution from that equation, either from Newton-Raphson or the Gauss-Seidel. For this case, it has also two solution for two intersection between two curves. So if you just start the job for this case, that means from this side, say for example, initial value considering fourth quadrant value, any value 0.5 minus 1, your result will converge at this point, and you can find by Gauss-Seidel Newton-Raphson concept. So Actually, for this equation, first of all, how can you find the derivative? First step. The Newton-Raphson concept must have the derivative idea, right? This equation must, your first step is to derive or determine the derivative. For this case, as you have two equations, the derivative will not be the simpler like earlier case. It will have partial derivative, okay, rather than the regular ordinary derivative. It will have partial derivative. Partial derivative of this function, uh, the first part or this part will be determined, or you have to find the derivative of that part in terms of x1. Okay, so what will be the derivative response of that part? It will be 2x1.
2x1.
Right, 2x1. And for that second part, it will be derivative in terms of x2 variable. So ddx of x2 in terms of that function. Okay, so that part will give you 2x2, right? 2x2. So this 2x1 and 2x2 will form the Jacobian matrix sum like that. Okay, this is the Jacobian matrix of those two equations. For first equation, it was 2x1, 2x2. For second equation, it will be ex1, right? What about this one? It will be 1 only because it has the coefficient 1, right? So this will be the Jacobian matrix for the given nonlinear sets of equation. Okay. So if you can understand that part, that means it is the Jacobian matrix. So can you determine the Jacobian matrix for other function like this? This is the function you have been given, say for example, and you have to solve the nonlinear equation using Newton-Raphson method, and that Newton-Raphson method requires the derivative first step to determine the derivative, right? So to address this equation, first of all, first step is to generate the Jacobian matrix J based on the given equation. For first equation, what will be the partial derivative response? Can you find? What will be
Yes,
partial derivative response for that first equation? Because Newton-Raphson requires the derivative, and that has three unknown quantity or three variable. So what will be partial derivative response of that?
So 2x1 একটা হবে minus 2x2 একটা আর 2
right, 2x3 plus 2x3 for third. What about second equation? Second equation derivative.
Yes sir, doing so.
Sir,
Yes.
x1 plus 2x2 minus 3.
x1 plus 2x2 minus 3. Okay.
So first x2 হবে না স্যার, first x2 হবে না?
Sorry, হ্যাঁ, first একটা x2.
Yes, sir, x2 plus
x2 plus 2x2. Second part is not correct. Second part, it needs some correction. Tasin, second part.
No, yes sir, plus 2x2 sir, plus 2x2 sir.
2x2
হ্যাঁ,
এই part,
yes,
this part, because x2 has two.
এটা খালি x2 sir.
No, for x2 consideration when
exactly
you
স্যার, মানে addition হয়ে যাবে স্যার, মানে addition হয়ে যাবে স্যার, overall addition হয়ে যাবে একটা স্যার।
what will be x2 derivative for second
খালি
equation?
সেকেন্ড টার্মের জন্য হবে স্যার,
কি হবে?
এটা হবে স্যার 2x2, মানে x2 সামনে 2 চলে আসবে একটা
only,
কিন্তু পরে ওটা সামনেটার সাথে addition হয়ে 3x2 হয়ে যাবে
না, this will be 2x2 is okay, but you have to have x1 plus 2x2, right? Have you got that?
X. So
x1 plus 2x2 or
clear
second derivative.
confused.
A second equation, second derivative ta clear karo. X2, when you consider the partial derivative of second term, x2, that will be x1 as well, right? Because you have x1 for x2.
Oh, yes, sir. 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 ঠিক আছে,
So
sir.
x1 plus 2x2, that will be the derivative of x2. Okay. Sabrina, is it
ওই
okay?
টার্মটাকে নিয়ে করতে হবে, sir. Yes, sir.
Yes,
Right.
sir.
Right. Now I think you have got the point. Now, if it is okay, what about third equation? If you understand the second equation, what about third equation? Let's check whether you have got the point clear or not. To generate your Jacobian matrix.
1 minus x3 একটা
1 minus
1 minus
okay.
x3
Okay, second one.
তারপরেরটা 0 আর তারপরেরটা 0 তারপরেরটা হচ্ছে x plus
পরেরটা 0 কেন?
কারণ x ও না সরি স্যার ভুল বলেছি স্যার একটা ভুল বলেছি এটা হবে x3 পরেরটা হচ্ছে x3
রাইট পরেরটা x3 ফর সেকেন্ড টার্ম
থার্ড একদম লাস্টেরটা হবে স্যার হচ্ছে x2 minus x1
right x minus x1 plus x2 okay so that will be the Jacobian matrix right
yes sir
1 minus x3 okay 303 1 minus x3 is okay. Okay, 303. What about second term? It is correct or not? Let's see. That satisfy, right? That is the Jacobian matrix for partial derivative consideration of the given nonlinear equation, sets of equation, right? So that will be first step, the Jacobian matrix, okay? So when you have this type of multiple order of equation, Jacobian matrix, how can you address the Newton-Raphson concept? Can it be replaced? Actually, remember that Jacobian matrix set is the derivative set, right? So can we rearrange or think of that general equation? This was the general equation, right? This part, the starting part. This is the derivative part, right? Or Jacobian matrix. If we just shift that partial derivative or the derivative part as J0, right? J0.
Yes, sir.
J0 will be, if we just take that J0 in the numerator, it will be J0 inverse, right? J0 inverse into del C0. Yes. This part will be there, inverse matrix. So for that case, try to find DDF of this one is there in your hand. This is already there. The initial value, I will give the initial value. Okay, remember that in your paper. Write that equation in your paper in terms of J. J0 inverse into del C0. Okay, in your paper, write that for del x0. Then we will address the second order scenario.
Sir, I didn't understand.
Yes, sir. Could
you have not got? Okay, okay. Okay, this part, the denominator part, it is nothing but the Jacobian matrix, right? Is it okay? Is this clear? The derivative part, this gdx of f, it is the derivative, right?
Sir, Jacobian matrix part, sir, আরেকবার একটু দেখাবেন।
Acha, regarding Jacobian matrix, actually, this is nothing but the partial derivative based idea, right? So this is the function, and actually, if we think of this function, this has three equation and three third order equation, right? And to address that, you have to generate the Jacobian matrix that will be this one. this will be the 3 by 3 matrix, right? But if it is single order, in that case Jacobian matrix will be only that part, right? First term or this part. That's the earlier problem solution. That means the Jacobian matrix is nothing but the derivative response, whether it is single derivative or it is the partial derivative. For this case, this part is the J, right? ddx of f, it is the J part. Is it okay?
Yes, sir.
Okay, if this is J,
মানে স্যার এই ম্যাট্রিক্সে খালি একটা এলিমেন্টই ছিল স্যার, এই ম্যাট্রিক্সে খালি একটা এলিমেন্ট ছিল।
একটা element, because it is single order or single undefined. So just to make that equation in general form, this can be written like J, right? This part, the lower part, and that J part, if we just take that in upper side, it will be J0 inverse, right? If you just multiply that there.
Yes sir.
So that thing you have to write in your paper. J0 inverse multiplied by del C0. Okay. Will be equals to del X0. This thing you have to understand.
স্যার এখানে ডেল সি জিরোটা আমরা কিভাবে পাবো?
Del C0 will be the earlier, that will be the same. Okay, I will show you. First of all, think of that this is the J inverse, right? Multiplied with del C0. That is clear? If that is clear, we can proceed for next step. Here it is the J0 inverse. Then you don't have this part. This part will be there. Multiplied factor, right? So multiplied factor, then we will start the scenario. .5 minus 1. Okay, for that, actually initial value for that case, for x1 it is 0.5 and x2 minus 1. This will be the given initial value for this case. Okay, 0.5 as x1 and x2 as minus 1. So if we start there from that place, actually del C0, regarding del C0, we can think of that equation. That means put x1 as 0.5 and x2 as what? Minus 1. 0.5 and minus 1, like the earlier case, and that will be subtracted from 4, right? Del C0 will be C minus f of x 0, right? Here's my point. Earlier case it was only one equation, and that the equation was del C0 was C minus fx 0, right? This is the equation. Del C0 was
Yes, sir.
C minus fx0. For this case, as C has the value and fx0 you have to determine. Okay. This case C1 is 4, C2 is 1. So you have that matrix, and the value will be there. That means subtract that function value from 4. Okay. 4 minus that 0.5 and minus 1. What will be the response of del C0 1? That means del C position 1. For first equation, 4
Sir,
minus
fourth-
this function, that means 0.5 and minus 1. 4 minus that.
So 11 by 4.
Okay, fraction value, please. Fraction, what is the fractional response for that? 11 by 4 will.
2.75.
Okay, fine, correct. Then similarly, find for that equation also. Put the 0.5 for x1 and minus 1 for x2 and subtract that from 1. Okay.
Sir, 0.3513.
Okay, 0.35. Let's check whether you have got, yes, 3.3513. So that's correct. 2.75 and 0.3513. That is the del C response. Okay. Then the Jacobian matrix concept. Jacobian matrix you have already in your hand, right? What is the Jacobian matrix? This one, right? Put x1 as 0.5, x2 as minus 1. Okay. 0.5 will give you 1 and minus 1 will give you minus 2, right? For first equation, for first position. And here you have
Yes, sir.
e to the power 0.5. What is their value equivalent? Exponential 0.5.
1.6487.
Let's check whether you have, yes, 1.6487. So 1 minus 2 and 1.6487, and that will be 1 already. So that will be the Jacobian matrix part. So now you have Jacobian matrix value, you have del C. Can you find del X from that? That means Jacobian matrix inverse. You have the matrix there, right? In your hand, 2 by 2 matrix, make an inverse and multiply that with del C. Okay. Have you got my point? This is the matrix you have got, or this is the matrix, right? Jacobian matrix response. When you put 0.5 and minus 1, you will have the Jacobian matrix something like that, right? Use that Jacobian matrix, make an inverse of that, this 2 by 2 matrix. Inverse matrix, generate inverse matrix of that 2 by 2 Jacobian. Have you make the inverse? 2 by 2 Jacobian.
Sir, একটু time লাগবে, sir. একটা
Okay,
minute,
okay,
একটা
okay,
minute, sir. একটা
okay,
minute.
okay. First step, inverse that Jacobian. Then when you find the inverse, multiply that with that del C. Okay, del C multiplication. The inverse del C. That's what we have mentioned. J inverse del C, because J is from denominator to numerator and it will have J inverse multiplied with del C.
Sir, আমি ক্যালকুলেটর ইনভার্স কেমনে করতে হয় ভুলে গিয়েছি, স্যার।
Manually it's easier. 2 by 2 matrix, it is easier to hand calculation.
Oh, yes, sir. Yes, sir. Yes, sir.
Manually it's easier than the actually calculator use, because it is 2 by 2, it's easier.
So 0.22327.
Okay, that is the J inverse result. J inverse result, multiply
sir.
that with del C. You have 2 by 2 1, right? Jacobian matrix with that this del C. When you have J inverse, write that equation in the right side and make the multiplication with that J inverse del C. Okay, find J inverse and multiply that J inverse with del C. Here you have J inverse del C. Del C value is there.
So 2.0474 আর 4.8852
এটা কি বের হইছে?
স্যার আমার 0.8034 ফার্স্ট এলিমেন্ট আর সেকেন্ড
Right.
হচ্ছে -973.
Right, you have got the correct. Who is the second one? Sabrina. Sabrina response is correct. You can check del x should be the same what you have got, right? Sabrina, this
Yes,
one
sir.
is the result. Okay, fine.
Yes, sir, it is the
Del,
same.
yes,
sir.
the same result is del x 0. So del x you have in your hand, and you have started your journey from where? This point, right? 0.5 and -1. That one you have to write in the column wise. Okay, x1 and x2 in column wise. 0.5 -1, and this one will be plus del x. Okay, so 0.5 and plus del x will give you this one, right? That will be the case, right? Actually, this one, this equation, you have got 0.5 and -1 there, and del x just now what you have got. So this summation will give you x1. Okay. So x1,
আমরা del x থেকে x এ কিভাবে গিয়েছিলাম স্যার?
del x to x, actually del x is there, it is the incremental condition, right? And what about the initial value for that? X plus del x, right?
Oh,
X is there, x
Yes,
is
sir.
0.5, that is actually in row wise, it's actually you have to write in column wise. Okay, because your function
sir.
is x1 and x2 in column wise. It's already mentioned, is in just for information, it's mentioned in row wise, but you have to write that equation in column wise, so that you can add the equation x plus del x. Okay, and you can see actually the simple equation,
Yes, sir.
0.5 and 0.8, if you made the column addition, it will give you 1.3, right? Simple addition. And if
Yes,
it
sir.
is -1 and this one, this will add to generate -1.97, right? So that will be your
Yes, sir.
x1. Okay, x1. So that's not the result. X1, you have to again put that x1 for which calculation? Del C, right? This is your x1 now. Earlier x0 was there, 0.5 -1. Now your x1 is 1.3 and -1.97. Okay. Use that value for the del C calculation, which is the equation. Equation is what? Write that equation. This one is the equation, right? C minus f of x0. This is the equation, right? So apply the same principle to generate second iteration. First iteration, you have got that result 1.3 and 1 -1.97. Have you got my point? Only just replace the
Yes.
Yes,
value,
sir.
replace the value of 0.5 and -1 with 1.3 and minus 1.97, and repeat the same process what you have done just now. For your clarification, I have given the result what you should reach. This will be the response for DLC, whether you have got that or not. Have you got DLC calculation from this new value? Put that value 1.3 and minus 1.97 for del C. Sabrina, have you get that?
Yes, sir. I'm doing that.
Okay, del C is like this. I think you have got the idea, right? Just
Yes, sir.
to,
এটাই আসছে।
Exactly, sir. এটা time লাগবে একটু, sir. মানে
right,
এখন, sir,
right.
instantaneous আমার
You
brain, sir,
you have to
মানে
just replace or exchange the value in terms of that response, and in that way, you can reach actually the result something like this after 5 iteration. Okay,
স্যার আমি
just
ক্যালকুলেটরটা পেয়েছি স্যার। আমার যে বাটনটা ছিল স্যার, ওই ইনভার্স বাটনটা রং উঠে গিয়েছে, এজন্য আমি খুঁজে পাচ্ছিলাম না তখন।
আচ্ছা ঠিক আছে, তুমি ক্যালকুলেটরও ট্রাই করতে পারো ফর টু সেকেন্ড অর্ডার 2x2 matrix. You can apply the regular manual approach also. So actually this is the result chart. Okay, regarding fifth iteration. Actually I just want to conclude that issue that after 5 iteration you can reach like 1.0042 as x1, and x2 will be minus 1.72. Okay, that will be the result for this case up to actually convergence of 5 iteration. So for these types of problem, that will be mentioned how much iteration you have to continue, and based on that concept you can see that third iteration, fourth iteration, actually they have the quite similar response. For third, fourth and fifth iteration, you can see you have x result as same, right? X1 and x2, both of them are same response, but for third iteration it was different. Though x2 is same, but x1 is different, right? So x1 is fixed at fifth iteration. So ultimately this is the solution. Though third iteration, fourth iteration, fifth iteration, x2 same, for x1 you have to continue up to fifth iteration to get the same result of the earlier iteration. Okay, that means what you have put as input you have got as output, same. So thank you all for
একটা
attending.
কোয়েশ্চেন স্যার, স্যার
Yes.
ডেল সি, স্যার 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 হ্যাঁ স্যার, সরি
Yes.
স্যার, লাস্ট কথা স্যার, ডেল
বলো।
সি যে ম্যাট্রিক্সটা ছিল স্যার, এটাকে কি আমরা কলমে বসাবো নাকি রোতে বসাবো স্যার?
They'll see this should be in column wise. All the
Okay.
text is also in
Okay.
column wise. Okay, though it is mentioned here, it should be in column wise.
Yes.
X1, x2 in column order.
Okay.
They'll see also column order. Jacobian matrix is already 2x2. It's already in square matrix, and all of them are in column format. Okay, so thank you. I think you have got the idea how to resolve the issue of nonlinear equation in terms of Newton-Raphson concept. And last but not least, I want to discuss regarding class test 2. Actually, I am thinking of class test 2 on first or second. Whether you have any quiz on first or second November. Do we have any quiz on that day? If not, we can think of 1st November or 2nd November as next quiz. Okay.